Good morning, everyone. Fantastic to be able to join you here this morning at Innovation Zero and to follow the Minister and to hear his messages around the importance of innovation, of new technology, and of working together. I'm going to talk to you a little bit about a pioneering opportunity in space-based solar power that can really make a significant contribution in all of those areas. So we have a fantastic long-term sustainable energy source in the sun, shining through the roof here today. And the concept of space-based solar power is, in essence, very simple. It's about putting your solar panels, your solar arrays up in space and beaming that energy down to Earth. There are a number of compelling features that apply to space-based solar power. So firstly, it's abundant and scalable. So in a narrow band around geostationary orbit up at 36,000 kilometers, there's more than 100 times the energy needs of humanity in 2050. It's also scalable because the models and analysis show that we can roll these sorts of solutions out at a rate that can really make a positive impact on net zero timescales. Secondly, it's capable and consistent. So because your satellites are up in high Earth orbit, they see the sun all of the time, which means you get 24/7 baseload energy throughout the year. It's also dispatchable, which is really important for the future functioning of the grid. And one of the things that gets me most excited then is about its flexibility. So again, up in high Earth orbit, you can see over a third of the Earth's surface. And the satellites can switch the beam from point to point to any receiving antenna within its field of view, which gives all sorts of opportunities for reimagining and improving the efficiency and operations of the grid in the future. It allows us to, if we wanted to, chase the highest spot prices, but probably more importantly, to actually increase the accessibility and democratization of energy supply throughout the world, because it's not quite as compelling as GPS, where you've got these expensive satellites and we're just simply carrying a mobile phone to access the data. But it's similar. The expensive asset is up in space, and the receiving antenna on the ground is a relatively low proportion of the costs. So here's a depiction that starts to show that beam switching. I'll just start to unpack a little bit more the concept of space solar power. So the reason the economics works is because if you put your solar panels up in space rather than having them on the ground in the UK, you get 13 times more incident energy. That, combined with the fact that they're hypermodular systems comprised of the same hundreds of thousands of the same dinner plate sized modules, means that you can drive mass production economics through the system and really come up with a compelling economic case. These are large structures. They're kilometer scale structures, so more than 10 times the size of the International Space Station, but importantly, only 4 to 5 times the mass. And one of the reasons space solar power hasn't been a thing to date is because of the cost of launch, lifting these 2,000 plus ton infrastructure into space. But the advances with reusable rockets now have meant that we've seen orders of magnitude improvement since the days of the space shuttle, and orders of magnitude to come. So they're different concepts. Some use lasers, some use microwave. Most use microwave to beam the power down to Earth. You'd pick a transparent window, in a transparent atmospheric window, and then, importantly, that microwave beam is designed so that the maximum intensity is a quarter of the midday sun. So it's designed inherently to be safe and has retrodirective pilot beams, so again, ensure safety as it beams down to the receiving antenna or rectenna on Earth. There have been 3 independent studies done by a number of governments over the last year or so, and all of them have come up with similar conclusions, that space-based solar power is now both technically and economically feasible. And this is the chart really that's got the UK government excited, because what it's showing is that if you look at you've got the sort of important baseload technologies, clean baseload technologies there, but what space solar power, the reports are showing, is that it comes up with a levelized cost of electricity similar to the intermittent technologies, but delivering baseload. And clearly all these numbers are evolving in positive directions, which is fantastic. But there are lots of reasons that we should be looking at space-based solar power as a really credible option for the future, because yes, it's a big engineering challenge. The physics is completely understood, unlike some solutions. But actually there's lots of reasons for upside as well. There are other compelling features, such as the land area usage, which becomes important as we become land constrained. So it's 40% of the terrestrial, the equivalent land area for terrestrial solar, and 8% of terrestrial wind. Strathclyde University have done an end-to-end life cycle analysis showing that the carbon footprint's about half that of terrestrial solar. And as we start to understand the carbon impacts of mining and mineral extraction, because it uses high concentration photovoltaics, it uses around 1/6000th of the rare earths versus terrestrial solar. And the unit economics for these systems, once in production, you're looking at about $2 billion per gigawatt, which is very, very attractive compared to other solutions. So there are now programs, significant programs of scale developing in the US, in China, in Japan. And in the UK, we've got some real advantages. So there are a range of different designs. One of the challenges of space-based solar power is that as you go around the orbit, you've got to be able to both follow the sun and point at the Earth all the time, which is challenging. And most designs end up with a huge rotating joint with very large voltages passed across it. The design that the UK government study looked at has a unique solid-state approach. It's a bit like a phased array radar and has the ability to beam a bit like a lighthouse. And that gives all sorts of advantages because all of the elements of the system are used all of the time, which reduces mass, which reduces cost significantly. It's a hypermodular structure which builds all sorts of resilience into the system and redundancy. And then one of the other challenges for many of the systems is that they need to be effectively in geostationary orbit up at 36,000 kilometers. The laws of physics mean they then need to be very large systems. And the minister talked about investors, but actually, if you go into investors saying, can I have a couple of billion straight off, it's not a very straightforward conversation. This design does allow smaller intermediate products and hence a more investable roadmap. So the other advantages that the UK has are the holistic approach, the commercial approach it's taken to try and deliver on net zero timescales. The other international programs are very much government R&D or defence focused. And what we've created in the UK through the Space Energy Initiative is a unique coalition of the willing, bring together industry, academia and government that's really created the environment to work together to really make this happen. So there's now over 80 organisations across space and energy. And right from the start, importantly, we've looked at all of the elements that can make this a reality. So yes, technical, yes, finance, but environmental, regulatory, supply chain to really bring the benefits to the UK and globally. So there's lots and lots of benefits that can be delivered to citizens globally and huge alignment to UK government priorities. So hopefully it's been clear the potential benefits for net zero and for energy security. But the economic journey is fantastic. So the development programme for the concept that was studied by the UK government, there's 143,000 job years over the development programme. And in realising this, you're creating incredible new industries of the future, from wireless power transmission through to robotic assembly in space. And that can have incredibly positive impacts across the UK, from semiconductor opportunities, say in Wales or the Northeast, and all sorts of opportunities in robotics or space clusters that are scattered across the UK. It's a great opportunity for UK leadership, both around net zero and economic prosperity, bringing the sorts of international coalitions together that can really make this a reality. And it also grows space capabilities. So our adjacent economic sphere, the capabilities you build in assembling and constructing space-based solar power, builds the skills to enable us to build all sorts of infrastructure in space that can have huge sustainability benefits. So the journey is starting now. Partnerships are building, investments being sought. Really encourage anyone who's interested to come and have a conversation. It would be absolutely wonderful to work together at pace, to make this journey a success. It's a journey that can have huge net zero benefits, create industries of the future, open up a whole new economic frontier in space, and deliver a very, very bright future for the next generation. Thank you.